Rosalind Elsie Franklin, born on July 25, 1920 in London, England, was a brilliant chemist and pioneering X-ray crystallographer whose work revolutionized our understanding of DNA, coal, and viruses. Despite a tragically short life, ending in 1958 at just 37 years old, Franklin left an indelible mark on science, laying foundational stones for molecular biology and virology. Though often overshadowed by her male contemporaries, her meticulous research and scientific precision were instrumental in unraveling one of the greatest mysteries of life: the structure of deoxyribonucleic acid, DNA. Beyond DNA, Franklin's achievements spanned multiple domains, from aiding wartime research to revealing secrets of the tobacco mosaic virus, making her one of the most important scientists of the 20th century. Early life and education. Rosalind Franklin grew up in a well-educated and affluent Jewish family in London. From a young age, she displayed a keen intellect and a passion for learning. Her academic brilliance became evident during her years at St. Paul's Girls' School, one of the few institutions of its time that encouraged girls to study science. Her love for chemistry led her to Newnham College at the University of Cambridge, where she pursued a degree in physical chemistry, graduating in 1941. At Cambridge, she won a research fellowship that allowed her to continue scientific studies, though her academic path was soon influenced by the global upheaval of World War II, wartime work, and doctoral research. With Europe engulfed in war, Franklin chose to leave her fellowship in 1942 to contribute directly to the war effort. She began working at the British Coal Utilization Research Association, where she studied the properties of coal and carbon. Her work was not only scientifically significant, but also critically important for improving fuel efficiency and safety during the war. This research formed the basis of her doctoral dissertation, and in 1945, she earned her PhD from Cambridge. Even early in her career, Franklin's dedication to precise, high-quality data set her apart. Her studies on the microstructures of carbon materials contributed to understanding how coal transforms under high temperatures, a process essential for the development of graphite and industrial coke production. X-ray crystallography in Paris. After the war, Franklin moved to Paris, where she joined the Laboratoire Central des Services Chimiques de l'État under the mentorship of Jacques Meyrin, an expert in X-ray diffraction. There, she honed the techniques that would define the next chapter of her career. X-ray diffraction is a method used to determine the arrangement of atoms within a crystal. By analyzing how X-rays scatter when they strike a crystalline structure, scientists can infer molecular shapes and patterns. Franklin mastered this technique and soon became an expert, applying it to analyze carbon structures and their conversion to graphite. These studies were critical to the coking industry and marked her growing reputation as a methodical and innovative scientist. The DNA breakthrough at King's College London. In 1951, Franklin returned to London to work at King's College in the newly established biophysics unit led by physicist John Randall. There, she was tasked with studying the structure of DNA, a molecule still shrouded in mystery at the time. Using her expertise in X-ray crystallography, Franklin captured some of the clearest and most detailed images of DNA ever seen. Her work focused on two forms of DNA: aDNA, which is dry and crystalline, and bDNA, the wet form found in living cells. Her most famous photograph, known as Photograph 51, provided critical evidence that DNA had a helical structure. Although Franklin herself was cautious in drawing conclusions, her meticulous work laid the groundwork for a scientific leap forward. Her data, without her full knowledge or consent, was shown to James Watson and Francis Crick at Cambridge University. With this vital clue, they were able to propose the now famous double helix model of DNA in 1953. While Watson and Crick received a Nobel Prize for their work, along with Maurice Wilkins, Franklin's contributions were largely overlooked for decades, yet many now recognize that without her precise experimental evidence, the discovery might have been delayed or misdirected. Legacy beyond DNA. After her tenure at King's College, Franklin moved to Birkbeck College in London in 1953, joining the crystallography laboratory. There, she shifted focus to studying viruses, particularly the tobacco mosaic virus, a rod-shaped virus that infects plants. Her investigations revealed that RNA, the genetic material in tobacco mosaic virus, was arranged in a single helix strand wrapped within a protein shell, not in a central cavity as previously thought. This work, though less publicly recognized than her DNA research, was pioneering in the field of structural virology, influencing generations of virologists and molecular biologists. Franklin's collaborative style and leadership at Birkbeck also earned her the admiration of many colleagues. She mentored several young scientists, including Aaron Klug, who would later win a Nobel Prize for work built directly on Franklin's research. Challenges as a woman in science. Throughout her career, Franklin faced significant gender-based discrimination. At King's College, for example, she was not allowed to eat in the men's dining hall and was often excluded from informal scientific discussions where key ideas were exchanged. She was labeled difficult by some of her male peers, though many now view these criticisms as products of the era's sexism and a misunderstanding of her scientific rigor and high standards. Despite these barriers, Franklin never allowed prejudice to deter her. Her resilience, combined with an unwavering commitment to accuracy, remains one of her most admirable qualities. She maintained high expectations for herself and those around her, driven by a deep belief in the importance of getting things right, not just quickly. An untimely death. In 1956, Franklin was diagnosed with ovarian cancer, likely caused by prolonged exposure to X-ray radiation during her research. This was before modern safety standards were implemented. Even as her health declined, she continued her work with remarkable energy and passion. She authored numerous scientific papers during her illness and led a research team with undiminished focus. Franklin passed away on April 16, 1958 at the age of 37, at the peak of her scientific productivity. Her premature death meant she was never considered for the Nobel Prize in Physiology or Medicine, which in 1962 was awarded to Watson, Crick, and Wilkins for their work on DNA. Nobel rules prohibit posthumous nominations, posthumous recognition, and influence. In the decades since her death, Rosalind Franklin's legacy has undergone a significant transformation, evolving from that of a largely overlooked figure in the discovery of DNA to a widely celebrated scientific pioneer. Sparked by works like Anne Sayre's Rosalind Franklin and DNA and James Watson's controversial The Double Helix, public awareness of her contributions has grown, positioning her as both a symbol of scientific brilliance and a powerful representation of the challenges faced by women in STEM. Today, her name honors numerous institutions and initiatives, including the Rosalind Franklin Institute in the UK, the Rosalind Franklin University of Medicine and Science in the US, and a European Space Agency Mars rover. Her story continues to inspire new generations of students, researchers, and advocates for gender equality, remembered not only for her critical data, but also for the integrity, resilience, and quiet determination she brought to her work. The woman behind the helix. Rosalind Franklin's life and career are a poignant testament to the power of perseverance and the importance of scientific integrity. She was a trailblazer who changed the course of molecular biology, even if she didn't live to see the impact of her discoveries. Her story serves as a reminder that science is a collaborative effort, often driven by those who work behind the scenes, away from the spotlight. Franklin's ability to capture the intricate patterns of life on film gave the world its first real glimpse at the secrets encoded within ourselves. In remembering Rosalind Franklin, we not only honor a brilliant mind, but also commit to a more inclusive, fair, and rigorous scientific future. Her legacy, like the double helix she helped reveal, continues to spiral outward, influencing generations to come. And that, my friends, is the story of Rosalind Franklin, the brilliant mind who helped decode the very blueprint of life, one X-ray at a time. If you were inspired by her dedication, amazed by the DNA drama, or just love science with a side of history, don't forget to give this video a big thumbs up and subscribe to the channel. Got a favorite underrated scientist you think deserves the spotlight? Drop their name in the comments. We're always on the lookout for the next great story.